Okay, first things first, a little demonstration of what I'm talking about. Because most of these Cinelifters are X configuration with a certain amount of motors up and a certain amount of motors down, we've actually got the potential for quite a lot of redundancy. And the way that I see a lot of people wiring them together is basically just connecting all the power inputs so that it's essentially one system. And what we're doing here, if I plug into this connector, you can see that everything comes alive. I've got the flight controller on, so nothing unusual there. And of course, the same on the other side. That's all powered on. Now, the difference with the way that this sets up is if we imagine there was a battery connected here, and this for some reason went short circuit, obviously it would bring the whole drone down, but on this system, the way it's set up at the moment, I've got a metal pair of tweezers here. What I'm going to do is just touch those in there, and as you can see, the system's fine, it's still running. And what would happen in this instance is you would obviously lose either your top 4 or your bottom 4 motors. And then instead of having the power wires all connected together over here, I've actually got them split. So all the grounds are common, that's really important. All of the grounds always need to be connected, and anywhere that you run a signal wire, you probably want to run a ground wire as well. It's just good practice. But the two ESCs are actually separated by a fuse here. If you're going to run a fuse in series at the input here, obviously if the fuse went, you would just lose all power to the craft. So you really don't want that to happen. But the way that it's being used here, this is essentially kind of like it's more like a balancing wire on a battery. So if that's disconnected, both of the systems still work fine separately. The top motors or the bottom motors might draw more current in certain situations. So you want to make sure that your 2 batteries are being used equally. So you just need to make sure that you use a fuse that can accommodate that. But if either of the systems go short circuit, the fuse will go and you can limp home on the other system. Now it's definitely going to take a performance hit. And the next thing that we're going to look at is eCalc, which is a way of simulating drone builds basically, and we'll see what happens when we lose 1/2 of an X8 system on the Siccario. It's quite easy to just tinker with this software for hours, but in a nutshell, we've got the 2812 V3 motors here and a 4500 milliamp hour LiPo with the Hobbywing 60 amp, and then we've got the HQ prop 8 inches at a pitch of 4.5. So this is the Siccario, and you can see the configuration set up here, and there's a little diagram down here which shows it is X8 coaxial, and as it is, thrust to weight ratio is 2.1. We've got rotor fail, so it's saying according to these calculations, if a motor goes down, it'll still fly, which is great. I mean, we already know that, but it's good to see it all laid out like that. So what I'm going to do is take this all up weight here. So this is assuming a 2 kilo payload, and the whole thing all up is 4.8 kilos. And I've simulated that, but here this is just an X4 design. So what I've done is added more weight to account for the fact that once you lose either the top or bottom motors, they turn into just weight. Essentially, they're not providing any thrust, and you can see the thrust to weight ratio takes a real hit. It goes down to 1.4. Once you've just got the 4 motors, you no longer have rotor fail, and it's pointing out here that at maximum, at full throttle, just on the X4 configuration, when you've lost top or bottom motors, the motors might be getting pretty hot, and obviously that's a concern, but it's much better in theory than the drone just falling out of the sky completely. And it's something that, you know, you'll notice it on the throttle immediately, and be able to bring it back home. Now the next thing to try is doing this for real. So I've got everything set up, I'm going to take it to the field. So this is just the bottom motors powered. It's not very exciting, but it's still in the air. This is now just the top motors plugged in and still the 2 kilo payload. And it's interesting how the bottom motors spin up like that, but yeah, they are not plugged in. Just to sort of prove the point, it's just the downforce from the top props is spinning the bottom ones, but it does still fly. I'm now going to simulate a battery coming disconnected mid-flight. I've got 50 amps worth of fuses here, which should be enough to get all 8 motors off the ground, and then once I go beyond 50 amp current draw on one of the ESCs, these will go and 4 of the motors should come to a stop. And we've still got the 2 kilo payload here, which is a lot more than anyone's really flying with one of these, so it'll be interesting to see what happens. All right, here we go. So one channel's plugged in and the other side is just going to be powered by the fuses initially, which is then going to pop, and we'll see if we maintain stable flight. Oh, it flies so much better like that, I gotta say. There we go, perfect. Really smooth transition. Awesome. Phew, there we go. Just to finish up here, I will say, if you're going to try this, be aware that the craft handles the tune very, very differently when it's only running on 4 motors compared to 8, and it's quite susceptible to vibration at the best of times. So go carefully with the tune and test it as you would putting a brand new tune on it to make sure that it's all right. I'm actually going to be looking at making this airframe less susceptible to vibration, and that'll be the next video that I do. So if you're interested in that, hit the subscribe button. Thanks a lot.